This is the indefatigable Lima platform. It's the last remaining offshore rig in one of Britain's most productive gas fields. Made up of 2,500 tonnes of steel and almost 15 miles of pipework, it's brought over 1 million cubic metres of gas up from deep below the sea. For almost 40 years it's kept us warm, supplying gas to 5 million homes.
We were the young pioneers in those days. We were the ones bringing oil and gas to the UK. It was exciting.
Now, this giant is about to be demolished. It's going to be an immense engineering challenge.
You just keep watching it and your heart's going thump, thump, thump.
Diamond-coated wires will attack 2-inch thick steel.
It allows the machine to just keep cutting and slicing.
Gas axes burning at 3,500 degrees centigrade will bring it to its knees. It's an emotional time for the men who put her up. The North Sea Tigers.
That's 40 years of my life, now gone.
Taking her down will require remarkable technical skills and will provide a unique chance to see right inside this enormous installation.
Okay, could we get that hook reset, please?
This is Engineering Giants. Lima was at the heart of the indefatigable gas field, which was discovered in the 1960s, 70 miles off the Norfolk coast. Now the gas has run out and it's being decommissioned. The whole project will cost £1.5 billion and involve the expertise of more than 1,000 engineers. Removing every last trace of Lima will take 9 months.
I'm Rob Bell. I'm a mechanical engineer, and I've always loved to get my hands on complex machines to discover how they work.
I'm Tom Wigglesworth. I'm a trained electrical engineer with a passion for big machines. As Lima makes her last journey from the North Sea back to British soil, we'll be taking you through every critical stage of the engineering process. And as she's torn apart, we'll uncover the secrets of how one of the world's biggest machines works.
Few people know Lima's secrets, as well as Austin Hand. He worked on her construction at Lowestoft almost 40 years ago.
It started in Middlesbrough where it already slipped on schedule, so Shell decided to bring it from Middlesbrough down here to finish it off.
Right across here?
Just on a barge moored against the quayside, yeah.
Austin's come to meet 2 other Lima veterans, Bill Lindsay and Mick Needham. They haven't seen each other in over 20 years.
For a long time.
How you doing?
I'd like to say we haven't changed much, but I'm doing great, really. Yeah.
Probably the first time I ever come across you was on Lima.
That's right.
You know, that was who I am, and you were the main man.
For me, what's quite special is that you guys were the pioneers, really, of North Sea gas and oil exploration and getting the platforms out there.
It's exciting, but it's a big learning curve as well for all of us. We were only young lads. I joined Shell in 1971 as a 22-year-old, having worked in power stations, and didn't even know what an offshore platform looked like.
Yeah.
5 years later, I'm building them.
Yeah. In them days, the southern North Sea was quite a family unit. We didn't have too many people coming in as like international, and it was mainly local lads, and they kind of all stuck together.
Right.
And I think these days changed.
I mean, to your friends and family who weren't necessarily working in and around the gas and oil industry, the stories you must have been coming home with every week, they must have just been, what?
It was also difficult for the families, because if you're working in a shop or a factory, they've got a perception of what it looks like. But out there, they had no idea what it was like. And
no idea.
I know my oldest girl was only about 4 then, and I had to bring pictures home of a bed and a table with food on it. And she was happy then, but she just thought I was working in the sea.
Mick Needham's involvement with Lima started when she was built.
My relationship with Lima started in 1976
which entailed putting 3 new platforms in, and the first one was in Lima.
More than 30 years later, Mick finds himself back out in the North Sea, working on Lima again, at the very heart of the decommissioning process.
I got a phone call saying, we need a company rep on board the heavy lift vessel Stanislav Yudin taking out the Indy platforms. Would I be interested? And I said, too right, I would.
The challenge of working at sea makes the complex decommissioning process more costly, more difficult and more dangerous. Massive heavy lifting vessel, the Stanislav Yudin, weighing almost 25,000 tonnes, has moored up against Lima. This mobile demolition yard costs £500,000 to hire per day and will be home to the 120 engineers who will harvest Lima from the sea. Their first major job is to plug the wells and sever the gas conductors. The Lima platform had 6 wells, each tapping into a separate section of the gas reservoir 2 miles under the sea. The only way to bore that deep is brace the well in sections as it's drilled. Each time a smaller pipe is passed down and the join sealed with concrete. These are known as conductors. Now, Lima's wells have been plugged in 4 places with cement and the conductors are ready to be cut.
You end up with pipes within pipes within pipes, so you've got concentric rings of pipes. Once the conductors have been cut, you will actually see something that's like a dartboard effect, where you've got concentric circles within each other with concrete between them.
Cutting through these materials would be a challenge on land. But this surgery needs to be carried out 30 metres under the surface of a stormy North Sea.
Morning, gents.
Matteo Mosca helped develop an ingenious cutting solution, one of the many methods used in North Sea decommissioning.
So what have we got on there?
On this wire, which is just a steel strand wire, you got embedded these diamond bits, these elements which are covered with synthetic diamond.
Okay.
Then the wire is constructed as an endless loop, a continuous endless loop.
And it grinds its way through.
Yes, and gives a good finishing. It doesn't alter the physical structure of the metal. Locally, it doesn't heat it.
So can we actually see this cut through?
Yes, that's what it's made for. So let's go.
Back out in the North Sea, this process is happening 30 metres below the surface of the water. These cameras help guide divers as they manoeuvre the diamond wire cutter into place.
Let's get cutting.
The amount of friction created by the cutter can heat up the steel so much that it begins to warp, so it has to be cooled by water. The saw working out on the Indy field has the cold North Sea to do the job. But for this demonstration here on land, cold water must be sprayed on to dissipate the heat.
I mean, the thing for me, which really drives home this is quite a clever piece of kit, well, you've got thousands of tons compressing down, and this cutter allows you to cut across that without it getting jammed.
A jam deep underwater would halt proceedings and cost tens of thousands of pounds to put right.
Well, this, because it cuts all the way around that wire, not just forwards, but also above and beneath it. It allows the machine to just keep cutting and slicing right the way through. It's really impressive cut.
On Lima, with the wells plugged and the conductors cut, they'll be able to move on to a bigger challenge, removing the 2,500 ton platform. This scrapping represents the end of an era. The North Sea veterans who put Lima up know how tough it will be. 34 years ago, as a young man, Austin Hand helped to bring it into the world. Now, he's in charge of decommissioning on one of the North Sea's biggest projects.
Is this you?
That's me and my boss, Gordon Box, who was the guy who actually recruited me into Shell. I've been involved in that sense for 40 years, either design and construct, And initially, my first sort of foray into the offshore business was Indy Lima.
That's Lima in the background.
That's it, parked in the quayside in Lowestoft after we'd brought it down from Middlesbrough. So that was us beginning to get it ready to go.
The platform has to withstand 15-metre high waves and winds of up to 100 miles an hour. The legs, or jacket, is all important, fixing Lima to the seabed. Removing it is going to be a mammoth task and will require as much engineering ingenuity as went into building her.
So the jacket's basically a frame, and you place it on the seabed, then you put piles in, like pinning it, and you drive the piles with a big hammer into the seabed.
Yeah.
That is a piling hammer. So it's about 60 feet high. Now, above all these exciting things to do, one of my jobs was to stand out all night with a clicker, counting the number of blows of the piling hammer.
You got all the good jobs.
Lima's removal from the North Sea will involve taking away not just the jacket, but the piles as well. And before that happens, I want to understand exactly how she was constructed and secured out at sea.
I've got to show you how it works, though.
Okay.
Right, so obviously, on Lima, this was done a hell of a lot further out at sea.
Yeah. How do they actually get it out?
They built this on land, the jacket.
Yeah.
They've taken it out on a massive barge, though. But the jacket is basically only there as a guide for the piles. And these are what takes the whole force of the topside. So they go slot down into each of the legs. So on Lima, these piles were being driven 90 foot into the seabed.
Must be a very noisy job.
It is a very noisy job.
That's why they do it so far out at sea, so they don't disturb anyone.
That is going nowhere.
With the legs firmly embedded, the final part of the construction was to add the topside. Now, 40 years on, removing that topside is about to be the biggest test so far for Lima's decommissioning team. Weighing in at 1,350 tonnes, this is the heart of the rig, where the crew lived and worked, processing the gas before piping it to shore. Cutting it off the legs will be an enormous challenge, requiring knowledge, skill, and nerves of steel. The problem is, how do you cut across the legs but still ensure the platform stays in place until craned off?
If for some reason we had a storm blow up and we just did a straight cut, potentially the wind and the weather could vibrate the topsides and start to move the topsides. And if it's just on a flat surface, it could start to move. And potentially, the last thing I want to do is have to go fishing to get the topsides off the seabed.
Lives could be at stake if they get it wrong. And so a simple but ingenious solution is integrated into how they sever the legs.
The cuts are shaped like castle ramparts. These cuts are absolutely genius and crucial to the whole decommissioning process. Having made the cut through the jacket, the topside's resting on that. What the castellations do gives the whole thing a lot more structural integrity. But when you do need it to be lifted, the crane comes in and it's taken up. Genius.
The final castellated cuts are made to Lima's legs, leaving her 1,300-ton topside precariously balanced on top. The worst thing that could happen at this stage is a storm. The castellations could be brutally put to the test. But the morning sun reveals that Lima's topside is still in place. Now it faces a new test.
This part of the operation is incredibly dangerous. It uses a floating crane that can lift 2,500 tons. That's as much as the Blackpool Tower weighs, which is why it costs almost £500,000 to hire every day. Then, in order to float more than 2,000 tons of steel back to land, a barge is needed. This one is as big as a football pitch. At this moment, there's only one thought running through Mick's mind.
Is it going to be level?
The entire lift is based on complex calculations, which allow the crane to ballast itself against Lima's weight. But these calculations are estimates.
So you're doing a theoretical model of not only the topside's weight, but where the centre of gravity of that topsides is.
And they're about to find out how close to the truth they are. The platform is successfully lifted off its legs for the first time in 30 years. More than 1,000 tons of steel are manoeuvred with precision safely onto the barge.
With stage 1 complete, the engineers will turn their attention to the legs. These are embedded deep into the bedrock and must be cut off below the surface of the seabed. The task is tricky and will require an even more ingenious solution. But as preparation for Lima to leave the indefatigable gas field continues, I want to find out more about why she ended up there in the first place. For geologist John Underhill, gas and oil exploration is a lifetime's work.
I have this strange belief that under the sea, when you go drilling for oil, there exist pools of oil, pockets of gas, large, sealed off sections that we drill and tap into and then it all comes releasing out. Is that true?
Well, it's a popular myth, really, that we float on a reservoir of oil. In reality, it's solid rock with what's called pore space between it, so air pockets that can be filled with gas or with oil.
These air pockets, less than a millimetre in size, fill up with gas over millions of years. The pores make this kind of rock soft and easy to drill. So soft you can even feel it.
I'm moving grains of sand because they're coming apart and they're on my fingers. So that's breaking apart. That is a porous rock.
The very same rock formation that makes up Lima's gas field off the Norfolk coast travels the length of England and emerges on land here at Tynemouth in the northeast.
This is a core from the Southern North Sea, from the Indy field.
Can I hold this precious ingot? And from a sample like this, once it goes into the hands of the geologist and it's tested for all its components, you can then say how rich it is in oil or gas.
We can calculate how much gas is in the Indy field, for example, from this and from the mapping of the seismic data.
Geologists calculated that the Indy field contained 5.6 trillion cubic feet of gas, enough to fill nearly 2 million Wembley stadiums.
Under the right conditions, gas is formed from the remains of organic matter, compressed under rock for millions of years. This layer is known as the Carboniferous layer, or source rock. Above this, porous rock holds the gas like water in a sponge, in the gaps between its grains. Finally, a layer of hard, non-porous rock, known as the sealing layer, forms a cap, locking in all the gas, until someone drills a well.
There are two types of source rock. One is oil-prone and comes from either marine sediments or lake sediments. The other type is from woody material, coal, that gives a gas-prone source rock.
So it's marine life that gives us oil and then land life that gives us gas?
Primarily, yes.
And here, in the cliff face below Tynemouth Priory, we can see how the source rock lies beneath the sealing layer, identical to that found in the Indy field.
At the base, we've got the Carboniferous, which is the source rock level. Above that, we have the reservoir unit, the yellow sands. And above that, right at the top of the cliff, the recess at the top of the cliff, is the sealing unit, which keeps the gas in the reservoir underneath the North Sea. And all three are exposed here in this cliff line.
Out in the North Sea, with Lima's 1,300-ton topside removed, the next big challenge is to sever the 10-storey high 1,085-ton legs from the seabed. All trace of Lima must be removed to satisfy a so-called clean sea policy. triggered by a dramatic event in the North Sea 17 years ago. The Brent Spar was a gigantic oil storage facility from which oil tankers transported the oil to shore. By 1995, a pipeline had been installed, so it was no longer needed. Shell had a plan to dump it by towing it into the Atlantic and sinking it. Greenpeace saw this as a potential environmental disaster, so they sailed out and took control of the Spar, a protest that would make international news. In a blaze of bad publicity, Shell reversed their decision and instead towed it to shore to be recycled on land and put the rest of the Brent field decommissioning on ice. 17 years later, the process has restarted, and Austin Hand, who began his offshore career building Lemur, is in charge.
Did that kind of act as a precedent for now how all the fields and the platforms are decommissioned?
We thought it was a reasonable and logical thing to do, to take it out to sea, 2.5 miles down in the Atlantic, and place it in this kind of valley on the seabed. We didn't do a very good job of explaining that. So basically that resulted in the Oslo-Paris Convention of 1998 that said, roughly speaking, you put them there, you take them away. Okay. A clean seas policy. Okay. And that's what Greenpeace strove for, and that's what they succeeded in getting.
There's so much involved in this that the cost of decommissioning just must be enormous.
Austin's estimate, Austin's view, $100 billion.
Of decommissioning?
In the UK. There are those that would say, I don't believe you, Austin, you've overstated it. We'll see who's right in the end.
Because of the clean seas policy, out in the North Sea, the Lemur engineers now face a really difficult challenge. Cutting the legs of the jacket to remove it from the seabed in a way that leaves no trace that it was ever there.
To achieve this, the jacket legs must be cut off 3 meters below the seabed. This means the only way to cut the legs is to sever them from the inside.
It's a job that demands a very special type of cutter. As world expert George Jack explains, there's no blade, no flame, just water and grit.
Is it the seawater that you're using there as your...
Yeah, we take filtered seawater in through our pumps, pump it, take up the high pressure, and then introduce the abrasive to it as well. Yeah, that's the actual garnet we introduced to the water.
Oh, that's pretty hard stuff, is it?
Yeah.
Garnet is a dark red, silicon-based mineral. Although large crystals are used in jewellery, some types possess strong atomic bonds, which make them very hard, and ideal as industrial abrasives.
If you don't have that in your water, there's not enough friction to cut through the actual metal.
Okay. George is about to demonstrate to me the power of cutting with water and garnets.
This is a control room. This is where we control the water pressure, the grit monitor.
Okay, so what pressure are we at here at the moment?
Just now we're sitting at just 6,000 psi.
Okay.
That's 300 to 400 times greater than your typical water supply at home.
So abrasive on.
Yep, this is put your introducing the grit into the system, the pressure comes up.
There we go. Look at that.
You'll know when as soon as it starts coming through, you'll see the water coming underneath.
Whoa, now you can see it's just gone through. So that's 50 millimetres of solid steel, and that's just
50 millimetres, yeah.
So compared to, say, a high-pressure jet hose that you might get for your washing your car or doing your patio from the hardware store, if you tried to do that with this thing, you'd probably do more damage than good, right?
Oh, yeah. The pressure, we have barely read on one of these gauges. The first line on that, go up in thousands.
I'm not quite sure what kind of cut I'm expecting. Is it going to be a clean cut? Is it going to be quite jagged? I don't know. Here we go.
This is 10 minutes worth of cutting time.
That's clean. That's a really straight, clean cut.
Yeah.
Bit the old Paul Daniels, Debbie McGee. It's gone right the way through. Yep. Right, so this is not for domestic use?
No, not for domestic use, I'm afraid.
The Lemur engineers are ready for the high-pressure water cutter. With the topside removed, they're able to lower it down right inside the legs. In theory, if the severance isn't complete, the crane could pull the Stanislav Yudin over. In practice, fail-safe mechanisms would prevail, but an incomplete severance could still cost millions.
We control it from the top side using our hydraulics and everything.
Okay.
And it'll do a 360 degrees sub-sea, just 3 metres below the seabed.
Before they begin the cutting, every precaution must be taken. The system is pressurised to 6,000 pounds per square inch. Any leak or breach could be deadly. An exclusion zone around the cutter is strictly enforced.
Because we've got high pressure hoses running across the deck, if you put your hand up like that, you're not going to have anything left.
Calculations estimate that the 360-degree cut of each leg should take 75 minutes. All Mick can do now is time it and hope. Once the allotted time has been given to each leg, special slings are attached.
So all the slings they're not just something you get off the shelf. All these slings are engineered and designed and built to the length required.
Now the crane must ballast itself against an unknown payload. Up to 300 tons of extra weight in marine life could have accumulated over 4 decades, making the jacket 1,400 tons, as heavy as 7 jumbo jets. All this makes the calculations for the stability of the crane more and more difficult. Puts the ballasting power of the Stanislav Yudin yet further to the test, and their stability in more jeopardy.
And then the big tense moment for everybody. Because we are now going to start to lift the jacket, but there's one thing we can't do. We can't actually 100% guarantee they're cut by going to have a look at them. You hear the crane driver, he starts taking the weight on the crane. 1,200, 1,400 tons, somewhere in that region. And if he gets to 1,400 ton and then he starts saying, I'm at 1,450 now, you're thinking, I hope this is going to move shortly. And your heart's probably going thump, thump, thump. And then all of a sudden, it just seems to go, oh. And it's a great sight, that. And it's a great relief.
After the final lift, engineers work through the night to fasten Lima safely to the barge, upon which she'll make her final journey.
And that was it. It was an end of an era for not only myself, but for so many people that have worked on the Indy field throughout the last 40 years.
In the dead of night, she leaves the Indy field behind forever and sets off on the 200-mile journey home to the northeast. Mick's relationship with Lima has finally come to an end.
Indy produced for so long, brought lots of people work, and more than that, lots of great friends and happy memories. I think that's what'll stick. I'm no joking up. Ah, dear. I can't believe that. Excuse me.
But for Lima, this marks the start of the next phase of deconstruction. As dawn breaks over the horizon, Lima arrives at the mouth of the River Tyne. From here, she'll be taken to the famous Swan Hunter shipyard for demolition.
It's amazing to think something like Lima, how important that was to us. We just don't really consider that at all, really. It's delivering all that gas to our homes, keeping us warm, cooking our food.
Well, the Indy field actually produced enough gas in its lifetime to power the UK for a year and a half.
Just in one gas field?
Yeah.
At the Swan Hunter shipyard, they must wait for the tide to be just the right height so the barge is level with the quay. Only then can the painstaking process of sliding over 2,000 tonnes of steel off the barge onto land begin.
You don't see one of them come over every day, do you?
4 remotely controlled bogies with a total of 56 axles, each capable of supporting 36 tonnes of weight.
Fantastic.
Manoeuvre Lima into her final resting place. Now, the next chapter in her story is about to begin. Ivan Rain is Geordie born and bred, and is another person whose relationship with Lima and her sister platforms goes back to their construction in the 1970s.
But you didn't have to wear all this kind of stuff back in the 70s, did you?
Yeah, we did, but once you got offshore, if you ever mentioned the word safety, you're on the next helicopter home again.
He too has come a complete circle. He's now here to oversee the demolition and recycling of Lima.
All these pipes and valves and kind of meats, everything we can see around, it's all dedicated to getting that gas up out of here.
The main function of this platform is to gather gas from the seabed, and the gas will be brought up through 6 pipes, brought into this system here, and then redirected to another complex where it is collected, and then it's sent to the UK mainland for refining, and then it gets redistributed throughout the UK, and it comes into your house, and that's what you use for cooking your roast beef on a Sunday.
For Veolia's recycling team in charge of the demolition, this is no ordinary takedown job.
So this has been out in the North Sea for 40 years. Where do you start in taking it all apart and recycling it?
The heli deck will be cut off and pulled over, and then they'll start dismantling it section by section. Once that's flattened, they'll start cutting it up into very manageable pieces. And the smaller the pieces, the better the value they get for recycling, for transport off the site.
All right, so now we're talking money. Typically, you know, what are we looking at for recycling this whole platform?
Could be looking anything from 180 to 200,000 pounds.
Wow.
Scrap value.
After 40 years of service, providing gas to millions of people, and jobs and even a home to hundreds of North Sea tigers, Lima is finally about to be brought to her knees.
First, her infrastructure is weakened by strategic cuts. Next, it's time for the excavators to really get to work. Steel wires are attached to the helideck, and the machines go into reverse.
This red accommodation module is next for demolition. Its fixings to Lima's frame have been severed, and the excavators are standing by. Mick Cubitt spent 4 years living and working on Lima as an electrical engineer. It's almost 19 years to the day since he last saw her.
The place is incredible. It's like a bomb. A bomb has hit the place. In fact, it's bordering on unrecognisable.
I don't want to pull any more emotional punches on you, Mick, but I think that is your old bedroom, that red tin shack over there.
I'm afraid so. I spent several, in effect, the equivalent to 2 years' worth. So it's somewhat...
4 years, half on, half off.
That's right, yes. Some 700 nights spent in that little tin box.
So we've had to walk into your accommodation block, Mick. This is home sweet home.
Home sweet home looks fairly devastating to me. It's been... really had the insides ripped out of it now.
So this was the living area then, Mick, was it? This is where you passed the time?
Well, prior to the introduction of satellite television, we used to show films that were hired in by the company.
Like your own little blockbuster?
Yeah.
So, Mick, this must have been pretty cramped. How many people lived in here?
This was accommodation for 8 people, two lots of bunks. The shower for all 4 was in here. That's the shower tray with a wash basin placed just here.
Shower, wash basin.
And that was it. That was your emergency exit.
So, Mick, it's the middle of the night, you're asleep in your comfortable abode, and there's an emergency alarm, the worst case scenario. What's the order of service?
3 offs. The 3 offs being block off, where you would block in all the wells, stop the gas coming onto the platform. You would then vent off.
And what's the 3rd off?
You just off. Follow me.
Okay. Quickly, Mick. It's an emergency situation.
For Mick's Lima colleagues, reunited in Lowestoft for the first time in over 20 years, all that's left are photos and shared memories of their incredible offshore lives.
Is that you? Is that you, Pete?
That's me on Lima.
How many times would you have been offshore at that stage, do you reckon?
Probably not many.
Yeah.
You never used to fish, didn't we, Tony?
Sure, there is some entertainment to be had.
Made our own entertainment.
What was the food supplies like? I mean, did you eat well?
Ate very well. But you would have a choice of a fillet steak, a bit of fish.
That's a decent spread, that, isn't it?
It is indeed.
Christmas crackers.
Yeah.
Explosive devices offshore.
If you had a good chef, you had a good platform, and you had a productive platform.
That's one thing I really take away from this whole process is it isn't just the hardware. It isn't just all the steel and everything there. It's the family of all the people who've built it, worked on it. How does it feel now that particular field and Lima platform's not there anymore, is it? Does it kind of sit with you, does it rest with you, or...?
When you finish, you think, you know, that's 40 years of my life.
Yeah.
You know, now gone.
You just realise how old you're bloody getting.
Back at the Swan Hunter shipyard, another relic of the glory days of the North Sea has been uncovered. A stark reminder of just how treacherous it can be.
So this looks like a horror story, Mick, but I believe it was just the heli deck. When they removed it, it smashed into the front there. But this is your survival raft, isn't it?
Yes, this was the Brooker capsule, as it was known on the platform. Awful thing to steer, being circular, and an awful thing to ride in.
Were you the captain, was you?
I have been done the coxswain's training on here, and I've been to sea with guys who are happily throwing up, and it is not the best place to be, even with a dozen guys in, when you've got a couple of them throwing up into their hard hat.
I'm hoping that years of training means that my Lima veterans have grown stronger stomachs, because I'm about to get my first taste of the Brooker pod experience.
And this is exactly the kind of one you had up on Lima, is it?
Absolutely, yes, identical.
Identical. Well, luxurious, was it?
No, that's how we became friends, you know.
Pods like these have safely evacuated more than 2,000 people in over 60 incidents around the world since Lima was built.
So how long since you guys have been in one of these then?
For me, it would have been 1978 in this particular type.
I've been given the job of releasing the capsule, and it's fair to say that the speed of the response takes me by surprise.
Right, we're off.
They were designed for the Gulf of Mexico, but the bobbing donut was no match for the waves and currents of an undulating North Sea. The survival pods, still vital for an industry which has claimed hundreds of lives, are now usually boat-shaped. I'm being shown the ropes by Nick Goldspink, who's been teaching North Sea Tigers how to navigate these pods since 1989.
I mean, we're moving around like a boat, but still this round shape seems like a very odd design for a boat to me.
Yeah, it's partly to do with strength, and it's partly to do with ease of operation. The traditional style of lifeboat has got a cable at the front and the back, and there's a chance that that can hang up. There is no chance and no possibility to that with this shape of boat. Obviously, there is a compromise to the shape, and that is that they do bob around like a cork.
Round boat though, so how do you even steer this thing?
Yeah, well that is more difficult than a traditional lifeboat shape, but the advantage of that is they're very manoeuvrable. But she's steered basically from the tiller here, which again is unusual in a lifeboat to steer a boat from the front.
If you were to evacuate, how long would you be able to survive in a craft like this?
A fairly long while would be the answer to that. I mean, there's enough water and food for a week.
I would not want to be stuck in here for a week with 27 other people.
You'd get to know them fairly well.
You would become quite an intimate team.
So how was that, gents? Bring back a few memories?
Yep.
I have to say, 20 years on, I never thought I'd be back in one of them.
Back on Tyneside, there's nothing ship-shaped about Lima, which has been slowly cut down girder by girder, making it no longer possible to trace the pathway that gas would have taken, snaking through miles of Lima's pipework from under the sea to our kitchen hobs. So to solve the mystery of how she worked, I'm going to see an offshore platform in action and trace the fossil fuel route.
A little bit anxious. Never been on a helicopter before.
Thanks to gas and oil, Aberdeen Heliport is Europe's busiest, ferrying almost 500,000 passengers offshore every year. Across the North Sea, more than 100 lives have been lost since air transfers began, which is why every possible safety technique is used.
I'm terrified. Absolutely terrified.
In the event of the helicopter ditching, this suit will increase my survival time in the freezing North Sea from just minutes to about 7 hours. But I hope I don't have to put it to the test. After an hour of seeing nothing but sea, a platform comes into view. 100 miles offshore from Aberdeen in the northern North Sea, this is Nelson, which produces both gas and oil. The fossil fuels pathway on Nelson is very similar to Lima's gas pathway, so I'm going to track the route from under the sea to our homes and explore how current technology works. While Lima had 6 wells, Nelson has drilled 28. Nelson's manager, Nick McLeod, is going to show me the drill floor.
Okay. Wow! Pretty impressive drills there. Our wells here could go down as far as 20,000 feet.
20,000 feet?
Yeah. And eventually we get down to what's called the pay zone, which is the area, the pay zone. That's where the money is.
Yeah.
That's where the oil and gas is.
Okay. What happens then? It calls spurts up, doesn't it? And everyone cheers. Is that right?
In the old days, hopefully not these days.
The first crucial stage for the fuel that emerges is the well bay.
Everything's moving about and juddering. Really noisy. Absolutely unbelievable. It's unbelievable to consider that they've made this size of machines. It's even more incredible when you realise that we're 100 miles off the coast.
Production engineer Murdo MacDonald is here to explain the first step of the fossil fuels pathway.
Oh, there's not a lot of room in here.
Which involves something known in the trade as a Christmas tree.
Why is it actually called a Christmas tree?
Maybe it's because they look like they've got branches coming off them. You've got all the gauges hanging off.
You've got quite an imagination if you...
Yeah, you've got quite a strong imagination. You have to with 2 weeks offshore.
Yeah, that's what it is.
When a well's drilled, the raw fuel comes up the conductors into the well bay. On Lima, this was gas. On Nelson, it's gas and oil. Here, the Christmas trees, large assemblies of valves and gauges, help control the flow of oil and gas entering the platform. I'm ready for my first offshore job.
5 turns. Oh, 1, 2, 3, 4. 5 turns. What have I done?
Just close the choking about 5%.
Just closed the choking 5%, which has restricted the oil flow coming up the...
Absolutely.
Stage 2 of the pathway is all about separating what emerges from the well into its constituent parts.
Like a science fiction film.
When a well is drilled, oil comes up the conductors into the well bay, but it's not pure oil. It's a mixture of oil, gas, and water. In order to extract the valuable oil and collect the gas, the whole mixture is sent to one of the most important devices on the platform, the separator.
I've made a model of Nelson's separator to explain to Rob how it works.
It's bafflingly simple. We have here a bucket, which to the casual observer appears to be a generic brand cola,
mixed with vegetable oil, which is actually exactly the same as oil, water and gas, right? That's what's coming up from the bottom of the sea.
So we've got a pump, but normally that's got enough pressure to be forcing itself up.
Exactly, that would be pushed up under its own steam.
Yeah.
So what you do, you separate them out. The gas will naturally float off to the top.
Yep.
Lighter than both of them.
So that'll normally be tapped and off into wherever else it needs.
That'll be tapped and processed, yeah. Water is heavier than oil. So this weir is very important because the oil floats on the water.
Okay, you see that easily here. So the brown stuff is the water and the creamy stuff is your oil.
Exactly. So because the oil is floating on the water, it flows over the top of this weir, creating this secondary chamber here, which is pretty much all oil. So coming out of here, you get pure oil. Coming out of the bottom of this section, you get flat cola or water.
Yeah.
Coming out the top, gas.
Gas.
This separation stage of the fossil fuels pathway is vitally important because it tells the energy company how much gas and oil they're producing. To do this, every day each well is taken out of production and diverted into the test separator.
You too? How's it going?
In the control room, Pete O'Connor is monitoring the results.
So that's the production valve there, the diverter valve, which is open. That's the test one, which is shut. So by putting it into the test separator, it lets us know how the well's performing, how much oil it's producing, how much water, how much gas it's producing. All our wells now are starting to water out. They're all over 80% water.
That didn't used to be the case?
No, they all gradually decline in oil production.
So the test separator is actually testing the mix of oil to gas to water?
For each individual well.
Yeah.
We have a spot rate there, which at the moment can tell you we're doing 19,357 barrels near enough today at the moment.
Wow.
At that rate, Nelson produces oil worth around £1.5 million a day. Not a bad return. The third and final stage of the fossil fuels pathway is exporting it. Water is cleaned and pumped overboard. Oil is cleaned and then pumped down the export pipeline to shore. But it's not all over for the gas. Some is exported to gas terminals. Excess is burnt off on the iconic flare stack. But most of it is diverted to something known as the gas lift to do an important job.
Because of the weight of the ocean on this trapped reservoir of hydrocarbons, it's all under pressure. Which is kind of like this. So the moment the drill pierces it,
wow, you've got oil.
The oil comes out. Now, obviously, quite soon it loses pressure. So once they've been tapping the oil off,
so it becomes like the field becomes flat.
Yes, exactly. It becomes flat. It becomes devoid of pressure.
Yeah.
So what you do, instead of pumping it up,
you
push gas down into the reservoir, which makes the oil light because it's got gas in it, which then sends it back up. You basically make the world's biggest soda stream.
The gas collected from the separator is compressed, repressurised and then re-injected back down the well via the Christmas tree, forcing more precious oil up. The force required to do this is huge. On the platform, Murdo shows me where they get it from. It's a gas compressor, which is essentially a jet engine, and it's one of the noisiest things I've ever experienced.
The engine drives a power turbine that drives the gas compressor. The gas compressor takes the pressure from 5 bar from the production separator, takes it all the way up to 147 bar.
That's 147 times atmospheric pressure.
That 147 bar is then used in the header to re-inject back down the wells to lift the oil back up again.
They're a powerful blow, aren't they, those jet engines?
I would say it's quite a blow, alright. Yeah.
But while Nelson's conductors are still full of North Sea gas, Lima's conductors now lie severed from the rest of the platform on the quayside at the Swan Hunter Yard near Newcastle. And demolishing them is going to be a feat in itself. Because of the way the wells are drilled and constructed, they end up with pipes within pipes within pipes, all sealed with thick layers of cement. Turning this into small pieces of scrap metal requires a process known as bombing. First, the gas axe is used to cut along both sides of the long steel conductor. Then, to get at the inner pipes, the excavator steps in. Once it's made short work of the concrete, the inner steel pipes are revealed and the process starts all over again. With over 1/3 of a kilometre of conductors to scrap, it's a lengthy process.
Meanwhile, on the other side of the yard, only Lima's legs, or jacket as it's known, still remain. Built from over 1,000 tonnes of high-grade steel, it must be broken up into small chunks to be recycled. The first stage is to bring the structure to its knees. Strategic cuts must be made so the legs collapse neatly. But it's a dangerous job. As soon as a cut is made, the platform is weakened and may fall at any time.
So are you guys responsible for felling the legs?
Yes, we are, yeah.
I wouldn't like to be the guy who does the final cut. Who's in charge of that?
Whoever wants to do it. The backside gets a bit twitchy when they're cutting the final.
I could well
doing the final
understand.
cut,
I mean,
yes.
I think if it was me, at the moment the axe is finished, I'd be turning and running. Do you actually...
No, there's no need to run.
In a carefully controlled and calculated procedure, tow lines attached to the top of the jacket will be used to pull it over. This is the first time this method has been attempted anywhere in the world.
We attach 2 ropes either side of the jacket and a safety rope to the very back of the jacket just to stop the back legs toppling the wrong way.
The engineers have put down a bed of earth for the legs to collapse onto to cushion the impact.
Got 2 lines, haven't they?
Yeah, 2 pulling lines. These guys will take the tension up on the wear. Just give it a little tug.
It's quite exciting, just the anticipation of it before it's going to come down.
Everything clear?
Clear.
Don't let anything in now because we're about ready.
All clear, Mick.
If the 30-metre high back legs were to fall in the wrong direction, they could land on a factory behind the shipyard.
Still excited to see these come down?
I love it.
Brilliant.
Well done.
Brilliant. That was awesome. Congratulations.
And that's the way to do it.
Things perfect, Ned.
The demolition of this jacket for recycling is the final act in the scrapping of the Lima platform.
Although veteran Lima engineer Austin Hand is working in decommissioning, he has not seen Lima, the platform he cut his teeth on, for 20 years.
Well, there she is now.
Wow. I'm so used to building things, so to see it dismantled and in pieces is just...
So you're probably quite used to it in this condition, in a sense.
I can still see the module, yeah.
Just on the different curve of its life.
Yeah, now that really reminds me of going on and off that barge for months to get it completed. Just walking over a gangplank and working 12, 14-hour days every day. But it was fun and exciting, so yeah, that gives me a bit of a buzz. You know, we were the young pioneers in those days. We were the ones bringing oil and gas to the UK. It was exciting. Good memories.
So I've seen, Austin, as this process has unfolded, I've seen the huge machine of Lima being reduced to small piles of steel rubble, and I was surprised to see so much timber on show. Can you tell me a bit about this?
Well, they used to say in my day that the rigs were made of wood and men were made of steel, but that's not actually true. So what this was, we covered the main steel deck with this timber, so that when you were lifting stuff off supply boats and landing it on the platform, you had some absorption material that avoided sort of damaging the deck or even the container.
So all this timber here was to provide you with a huge cushioned area to protect the whole thing, like a massive chopping board in a way.
Absolutely, yeah.
This steel tubing once formed the jacket that supported the topside. It's now been broken up into sections, ready to be recycled. But to the expert eye, even these fragments reveal the challenges of these early pioneering designs.
In the 70s, sometimes the quality wasn't great. So this is a good example here.
Yep.
Now this is a very tough angle for a welder to get in at these points.
You get right down in there.
Exactly. So, you know, in an ideal world, that brace would have been at a less of an angle, but very often the designers just wanted it to be structurally robust.
Okay.
And then when it arrived for us to deal with it in the construction yard, you think, wow, why did they do that?
Yes.
And
so on paper, mathematically, it makes perfect sense.
Exactly, but sometimes it wasn't constructible. But again, this was a learning process that we would feed that back in to the next jacket and say, can we do this slightly differently? And that's how we evolved the industry, getting better and better and making it easier to be sure these welds were sound and solid. All these things had to be considered, even with a relatively simple structure like a jacket.
For the final time, the excavators pull on Lima's infrastructure to bring down her last story.
Oh, the leg's going to go. There she goes.
Very, very sad to see that something that you built when you were a 25-year-old, you're pulling it to bits when you're a 59-year-old. And it just shows you time moves on and nothing stands still.
Lima is now unrecognizable, just heaps of rubble and thousands of tons of scrap steel. Amazingly, some 99% of this will be recycled. The wood from the decks is pulped and made into paper. Even the 300 tons of algae that collected on the legs will be recycled for compost. But most lucrative is the steel. Once the various grades have been separated out, it's then smelted and made into new girders and pipes. Fittingly, just half a mile down the road, steel from the smelted remains of machines like Lima are being used to build this.
A brand new 21st century platform. And to put it in perspective, whereas Lima weighed a few hundred tons, this weighs in at a whopping 12,000 tons.
Platforms like this are giving the North Sea a new lease of life. But Lima and its gas field are now just a memory. Removing it cost more than £200 million, took 2 years and over 1 million staff hours to recycle 2,000 tons of steel, 311 tons of algae, find homes for 2 generators and scrap 2 toilets and 12 well-worn bunks.
And ironically, some of the North Sea Tigers, who pioneered offshore platform installation, are now involved in the biggest new North Sea industry, taking them back down again.
Richard Hammond is here on BBC HD at 8 o'clock tomorrow with a journey to the centre of the planet. Next tonight, though, we're heading out on the world's most dangerous roads.